This is part 5 of section 4.4. Now we're going to talk about what we call phase shifts. This is our horizontal movement left and right. We call these horizontal shifts when we were talking about functions in section 1.5. Okay? And basically, if we have a number added or subtracted inside the argument of a trig function, we call this a phase shift rather than a horizontal shift. It's just new vocabulary. And just like when we did this in 1.5, this one sort of seems backwards. And it's because this value, when we get to the formula, it has a minus sign here. So here, our shift is going to be pi over 2, which means we go to the right. So if you have a minus sign, you shift to the right by that much. If this were a plus sign, then you'd be shifting to the left. So let's just talk about what happens when we have most of this mixed up together. Okay? So now we can have a multiplier in the front. This is the same b value we talked about earlier. But now we could have a number added or subtracted to our x value. Again, we're going to worry about our b value being positive because we can use our even and odd identities to always make that b value be positive. Okay, our first step. If the argument of the function has a coefficient on x, then we have to factor it out before determining the values of a, b, and c. So sometimes they'll give you a value with this function with this b value distributed. We just have to make sure we pull it out so that the coefficient on our x is 1 before we determine anything else. Okay? The amplitude is the absolute value of a, which is all we've been talking about so far. The period is 2 pi over b, so that is the same. And then the phase shift, how we move it left or right, is our c value. If that number is positive, and if c is positive, we're going to have a minus sign here, then we go to the right. If our c value is negative, which means we'd have a plus sign here, we're going to go to the left. Okay? The cycle always begins at c. Okay? And then it goes from c to c plus 2 pi over b. Now, before we had the shift, it was 0 to 2 pi over b. So this is just adjusting for that. If we have the same period, it's just going to be moved left or right. Okay? And again, we break up that period and we're going to add 1/4 of it each time. So in the previous examples, our c value has been 0. And so we had 0 and then our ending point, and then we've added 1/4 of it every time. Okay? Then we will plot our 5 points. It's going to follow the same basic pattern as everything we've been doing. And then if we must, at the end, if our a value is negative, we will reflect it over the x-axis. Okay. So let's graph y equal to cosine of negative cosine 2 times x plus pi over 2 over a 1 period interval. Okay? Now this 2 value is not distributed. That's a 1 there, which makes it all great. I don't have to worry about that. My a value is negative 1. So that means I'm going to have to flip this over the x-axis, but my amplitude is equal to the absolute value of negative 1, so the amplitude is 1. So we'll still be going up to 1, down to negative 1. Our b value is 2. So the period of this function is going to be 2 pi over 2, so it is pi. Okay? So that means, well, no, I'm getting ahead of myself. My C value is negative pi over 2 because our original formula has a minus sign here, so your C value always has the opposite sign of what is here. Okay, so I have here a note card with our basic data all together so that we can refer to it easily. We have one cycle over C to C plus 2 pi over B. So one cycle is going to be from negative pi over 2 to, we take this and we add our period. So negative 1/2 plus 1 is positive 1/2. So one cycle is going to happen between negative pi over 2 to pi over 2. Okay. Now we break this up into 4 equal parts. Our overall period is pi, so I'm going to be breaking up into pi over 4 each time. So my starting point, my starting x value is pi over 2. If I add pi over 4 to that, I get negative pi over 4. Add pi over 4, I get 0, and then keep doing that. And I have the x coordinates for our key points. Okay. Now remember, we get to go in the same order. Now for our cosine, if we're just talking about cosine of t, then it starts at 0 and cosine starts at 1. So normally this would go to 1. We'd multiply it by our amplitude, which is 1, so that means we're not going to have to multiply these. And then we go in our pattern. We start at 1, then 0, then negative 1, and then 0, and then back up to positive 1. Now this will give us our points for positive cosine of this. I'm going to lightly sketch this. If I'm at negative pi over 2 and 1, that would be here. And then these are broken up into fourths, so I'd go here. And our cosine function is just positive cosine will look like this over one cycle. I didn't graph that so well right there. Okay, now it's negative, so we flip this over the x-axis. To get that graph.